well done. Okay, so we think that the problem is with the getting and putting. When we put something and immediately get the value, the test seems to work, but the test seems to fail when we put all the values and then try to retrieve all the values, right? Doing it in batches like that, which tells me that there's some type of collision with the memory addresses. However, we already tested our coordinate conversion code in a similar fashion, and that already passed. So I think the problem might actually be with the bit packing. The bit packing is actually wrong. So what we're going to do is we changed the loop from the previous way we wrote it, and we took os and we brought it into the inner loop. So we're going to iterate over every single pixel of the data structure. Well done. This data structure here, we're going to loop over every single pixel, skipping the corners here. This corner here, this corner here, this corner here, this corner here. We're going to skip those corners because they're not useful. And we're going to set a different tile value. The tile value can only be between 0 and 3. So we're going to set one of those values and then see what happens. So, right, we're going to skip. This is where we skip these single pixels at the end of our kind of MIP map-like structure we have here. The first iteration, where put get is equal to 0, we're going to put the value, we're going to immediately get it, and we're going to hope that we don't fail. The next iteration, for the get, we're just going to get the values, right? Because we're going to generate the same values from this table, and we're going to expect to be able to get those values. And if this gotten value is not equal to the value we supposedly put, then we'll fail here, and if we do fail here, I'm going to be pretty certain that the problem is because of the bit packing. So we're going to give this a try. We're going to give this a run and see what happens, and that's all I wanted to say. So we're going to turn the music back on and just keep working, because I don't really have much to say, but when I do add these notes, I do want to talk a little bit to add some more context when I can. Okay, let's get going. Okay, so we screwed up somewhere. At some point when we were kind of putting braces all over the place, it looks like we messed something up. So we need to take a look here and just be like, okay, well, where did we possibly screw this up? And I think this was okay. The code we added was down here. So I'm going to take a wild guess and say that, yeah, that we did something horrible here. We can already kind of see what's going on here where this does not line up at all. How about this inner one? Does the inner one kind of line up with something? So this inner one totally lines up the wrong thing here. Oh, here we go. So we're missing the... So... hopefully that was it. Hopefully it's just some stupid mistakes. Okay, so I thought one of these tests that I wrote up here was going to actually get the problem, and it didn't. So that's telling me that it's actually the XY stuff, like something about we're setting something in the same exact pixel location for some reason. That's what that's telling me. So how are we going to figure this out? And I don't know. So I think the first thing we're going to do is this generating the val thing here. This is a little bit complicated. And there is the potential that that the value here is not being generated consistently for whatever reason. I don't think so. But let's kind of outrule that, right? We already have this thing failing, so if we can just get it to fail by having a hard-coded table, then that would be much better. So we have this offset thing here, right? So if so why don't we just make a little table here? I'm gonna just do something like that and see if we still get a failure. Test def fail, right? Let's see if we can get this to still fail if we get rid of that generation. I don't think it's that the number generation code that's causing the failure, but we need to outrule that to make sure that the problem is happening where we think it is, right? So we still have test def fail. The gotten value is 0. Got val was 0, but the val we supposedly were using was 1. Okay. And another thing we might want to say is, well, what's the offset index for this? And if this is the case, if this is failing, and we're trying to do this like loop over everything, this put everything then get everything, that's kind of telling me that the coordinate conversion for this stuff is not working, and so we should probably try to make sure that is proper, I guess. There could be something else, but yeah, so I think we want to test the coordinate conversion here of the underlying function. So let's see where we are, first of all. So we have this, like, Glock... Like, what is this test code? So put get. Okay, and what does put get inside of? Main get put tests. So we have a glockpix to painpix here. And I'm thinking we need another kind of test function for this, where I'm guessing this doesn't set everything. It does one then the other, I'm guessing. Well, the thing is, with these conversions, oh, so we just have, these are just very dead basic tests here. Right? So what we really want is more tests here. Yeah, these are very basic tests, so we should add more test code to them. That would be a good way to go. Also, we should just have a more general. So we have these specific cases, and then we should have some type of master case that covers everything, right? So I think down here we should have so we're running out of room, so we need to figure out what we're going to call it, and we'll call it this. Then we also need to set what test we're in. And it should not be called get put, it should actually be called put get, so we need to fix that as well. So let's just take this let's just take one of these. If I can do this correctly. And this should be put get, right? Always put then get. Okay, so now this is here. Test. So I'm thinking the problem could be here, that we haven't been thorough enough in these tests because we need to write more code for them. But for now, let's just do like a master test to say, yeah, the problem is probably in the conversion logic, but let's verify that quickly by just testing every single case. Because we know one of the cases, all these cases here pass, but they're very simple cases. I'm going to guess one of the more complicated cases is going to fail. So we could do like a big master loop here, and then when we find a specific failing test case, we can put it into one of these, and then write the proper fixes to make the test pass. I think that's what we're going to do. So, and we'll say, we'll call this 30 seconds. Okay. So, like I said before, these tests here, these conversions back and forth between the coordinates on this data structure here on my left, they don't have very many test cases, and I think it's not a thorough enough test, and I think the problem might be with the glockpix to painpix or the painpix to glockpix conversions. So we're going to do a mass test where we iterate through all 512 by 512 pixels of the bitmap that is storing this data, and do a back and forth conversion on them and see which possible values are failing. So I believe there's some set of values that is failing for this conversion test, so we're going to check that out and try to figure out what the problem is. So we're going to take this function name, just going to move down here. So this is main get put tests. Technically, this is a get put test. But I'm really, honestly, I'm losing track of what these sections are. So rather than accidentally insert something into a section where it doesn't belong, we're just going to say, you know, added on date 2021, and what's the actual date? 0107? We're just going to say that. We're just going to call this section this. Which is kind of hackish, but we are just in a sea of code. And we just want to get it working, right? So here we go. And void. This is also void. And then the function body. Okay. Now, we'll just keep a little note here of when this section was added. And now we'll just kind of add some loops to loop through everything and see what we can get going here. So, int32 px, int32 py, and okay. Do px, py. And inside here, what do we want to do? We want to convert back and forth. And we also want to make sure we skip the cases where they're not valid. So the cases where they're not valid, do we have them down here somewhere in our tables of stuff? Nope. So everything, code's all over the place. So, you know, if px, or if so we want to skip all of the corners. So 512, this is the top left. The top right is, oh, this is not the top left. Top left is this, right? 256 minus 1. The top right is, the x value has increased, but the y is the same. And now on the bottom, if we want to go to the bottom, okay, these are the tops. Here's the bottom, so the y's are already finished. But if we want to go over to the left, we got to do this. So 256, 512, 256, 512, and then 256 and 512, x's, and then y's. So, so we want to skip over the configuration pixels. That's what we're doing here. And at vid iid. 39 and 20. So when I'm saying skip over the configuration pixels, I'm talking about this data structure here in PAINT5D.data, and I'm talking about the single pixel here, the single pixel here, the single pixel here, and the single pixel here. So there's 4 pixels we need to skip over when we're iterating over the entire 512 by 512 bitmap. Okay, so if we don't skip them, right, use the continue keyword to skip, then we need to use the put and get functions to put a value and get a value. But it's not the put and gets, it's actually the underlying coordinate conversion functions we want to use. So glockpix to painpix and painpix to glockpix. We're starting out with glockpix because glockpix is the global pixels. So we can do this conversion this way. And our thought is that a simple conversion back and forth is going to fail us, is what we're thinking. So let's take this. And getting really sick of like copying and pasting like all these explanations here. But if we have the space for it, we might as well kind of keep on pasting the explanations down there, right? I don't really see any harm in pasting these explanations here, so let's keep doing that for now. So I noticed that these elements here should be pointers, like this, because this is the stuff we're trying to derive. So we'll surround them like that. And we have to set this up, right? So we have to set it up and say, hey, glow tx is equal to this px here. And glow ty is equal to this py. Glow tx, glow ty, right? Okay. So we also are going to need all these variables here. So we have U08s mostly, and then U16. So let's open up some space here, paste this down here, and we can steal the signature over here. We can steal those types, kind of paste them over here, make some space. Okay, so now we have all the variables we need to work with. We're going to do this conversion this way, and for the conversion the other way, we can just take all this code, we can paste it, and we just have to change the ordering of this. And, right, so painpix to glockpix rather than glockpix to painpix. That also means that we have to change what's wrapped here. So instead of that being wrapped, we're going to wrap the global. And the next thing is, for the test, you know, if glow tx is not equal to px, or alternatively, if the y, the global ty that we just extracted, is not equal to the pixel y, then we fail the test. Okay. So this is basically a brute force test every single possible value, right? And if this passes, then we're 100% confident that these conversion functions work, because we converted one way and then we converted back. So let's give that a shot and see if this catches anything, or if we end up with some type of problem where it still doesn't catch. I believe that we're going to see this error pretty soon. So let's give it a run. And then after that, I'm going to do some more push-ups and what. I want to get to at least 100. Actually, what I'm going to do is, I really don't want to do any more work today. So what we're going to say is that we're going to just keep doing push-ups until... Damn. I really thought that was going to catch it. So it seems like the conversion is okay. So let's do a log function at the end of this and be like, just log 99 for, I'm just gonna say 99% sure that pixel chord conversion works. So I'm going to take this and I'm going to say that I'm 99% sure that this works. So I am very certain that this works, and I'm very certain that the inverse of that works as well. Like, now we might want to look at this though and say, well, we set the value and then we got the value immediately, and that's fine. But right now they would be equal to each other, right? Because we set them equal to each other here. So we want to make absolutely sure that there's no, like, that maybe we're not actually returning, maybe we're actually not setting this reference. That could be a thing. So let's say glowtx is equal to 0 minus 333, because they're signed values, so we can do this. Right, so make absolutely sure. Let's make absolutely sure. Alright, so we're going to make absolutely sure of this. And if this test still passes, then we're 99% sure that these two functions work. Alright, so let's give it another shot and see what we find. And if we see the 99% sure message, then we have to... Then I think the problem... I don't know what the problem is, but I think I'm going to eliminate this and say, no, you're okay. So we have a lot of macro... So the log macro is not defined, and... Do we define that in a section up here, or where is that? Or is this... Are we still in test code? Oh god, this is ridiculous. There is just too much stuff going on here. I thought that we defined like in the top of the unit test, I thought we had like a log function. Okay, there's test code. More tests. More tests. Yeah, there's log right there. Maybe we're undefining it somewhere. So let's kind of look around here. Say log, 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 log. And then we have log. Oh, you know what? We're just not calling it right. We gotta have a 0 here. We gotta have a little void pointer. I thought it just didn't exist, because I tend not to read these error messages, just because usually the problem is obvious to me. When I know that there's a problem with the line of code, I usually can fix it right away. So yeah, 99% sure works. PAINT5D to Glock picks. Okay. And then we still fail over here. Okay, so let's take a look at this. So the got value is not equal to, yeah, so the problem has to do with how we're storing the data. And something is going wrong when we try to store and retrieve that data. So what I think would be helpful to solve this problem is to have the actual bit packing logic, put the bit packing logic into its own function, and see if we can test that. Because something with the put and get function I think is wrong, but it could be the actual bit packing logic. So if we look at the put function, okay, so here's our bit packing stuff. So we think that the problem might be the bit packing. And problem is how do we test? How do we test this? Yeah, I think it's the bit packing or bit unpacking, but I'm not sure how we're gonna write a test for this. I think this is a pretty dirty solution. So the global component plus 3 plus 2 plus 1 plus 0. And that gives us our UO8. So alpha, blue, green, or red, right? Red, green, blue, and alpha, right? That's the first. So the first component is that is the red byte. So so how do we get glowcom? Because glowcom is glowcom set, so here's a trap value. Okay, the global index. So xy to index, multiply by 4 to get that index. That looks correct. And we have this 0, 4, 8, and 12. What's that about? The offset dex. So let's look at P5D, PAINT5D, and look at this part of the diagram. And the offset dex, right? So here's our 12 and 15 that we're looking at. I'm not sure 1, 2, 3, 4, 5, 6, 7, 8, 9. I'm not sure why I numbered them like this. Okay, so here's the indexes that I really want to pay attention to. But y is... Zero, 4, 8, and 12. So I'm assuming alpha, there's a 0 because we're going to look at these, right? There's the minus 4, and we want to shift 1, 2, 3, 4 to get this in focus for the blue. And this is the minus 8 to get this in focus, and the minus 12 is to get this in focus. Like, that makes sense to me. And offset local is going to equal the offset dex minus... Okay, so that's how we get the local. Okay, cool. But we do that, but how do we get the correct shifting, right? So this bit shifting here is wrong, I think. Right, because the local offset should be, we should be shifting, we want to get at those bits, right? Or, oh, you know what it is? It's that, no, hold on. No, that math is correct, right? The reason why we have that, we need the local offset index is because the value isn't stored in an unsigned 32-bit integer. It's actually stored in these 4 bytes. So that's why that's that way. Okay. So the local offset index. And yeah, this math here this is some tricky math. It's some tricky bit shifty kind of stuff. So I wouldn't be surprised if, you know, something went wrong here. And how are we going to kind of test that out? Yeah, So binary 1, 1. Shifted over. We got the local offset index. And there's 2 bits per offset index. That's why there's a multiplication by 2. We invert them, and then we AND it, and those inverted bits, right? We create an inverted bit mask, basically. And we use an AND to kind of erase bits to get this bit pattern here. That makes sense. And then later we OR it with kind of an inverted deal here. We're going to shift this tile value into place. And this tile value already defined up here somewhere. Okay, tile value is actually an input, and we make sure that it's less than or equal to 3, so we have the right bit pattern for that. Now, the problem might not be in the inputs, it might actually be in the extraction of these values. So how are we going to write this math in a way where we can get these values, where we can kind of like reuse this? Because I'm going to guess that the problem is in our... Right, we're pretty sure that the problem has something to do with our bit packing. And if that were the case, it would definitely be some of this weird logic. I mean, this is the kind of logic where you think something would go wrong. And so we should probably kind of try to debug this somehow. And I don't know how, because we have this stuff directly into an array, and I don't know how we'll test it to make sure that, we want some type of helper function that can do this bit packing for us. That takes kind of like a array index and, it needs this. It needs the offset index. It needs this as an input. It needs where it's looking as well. So this could be an input. This could be an input. This could be input. This could be an input. Let's look at how we get the data. So when we get the data, so the old value equals this, and we return it. Ooh, hold on. We never put it back. Is that what's going on here? No, because we don't need... The get function doesn't need to... Alright, we're going to take this variable. We're going to shift it over the other way, and we're going to mask it. That's going to give us for our old value. That's fine. That's fine. It's the put, then, is the put wrong. Doesn't look wrong, because look, we're setting it here. Array index. And over here, do we have the array index here? Ardex is commented out, because we don't have to use it again here. Yeah, so something about this. We're going to have to figure out some type of way to test this kind of function here, because I think it's the actual bit shifting logic that is inside of these functions. So, you know, so we're going to make a little note here to come back to it in case we forget about this. So we might want to test this bit shifting logic in isolation somehow, because I think that's actually what's causing the problem. I just don't know how we're going to check it, right? There's a lot of stuff going on, and we need to really kind of isolate it. The problem is that we're kind of reading and writing to an array I guess every variable that's involved in this calculation, right? Even the offset dex is kind of involved in this calculation, right? So what we really need is kind of a I'm going to call this I'm going to make a new section called pixel bit packing. Right? And we're going to extract okay. 1 hour, 2 minutes, and let's call it 20 seconds. We're going to make a new section called pixel bit packing. And we're going to extract some of the bit packing logic that is in this section here, the put get functions. We're going to take some of that logic and we're going to try to extract it into some new functions. So all this kind of bit packing logic, oh, not that, the bit packing logic is down here. This bit packing logic, we want to extract that into a new section. So the first thing we want to do is, well, what are the functions involved? What are the variables involved in this? So osdex is a variable that's going to be used. Oslock is calculated in here. We don't need that. We need CPU pixels, so we need CPU pix, but we'll make it a variable. So we'll keep a reference to the memory that we're working with, so that'll make it a little bit more testable. The global component index, do we want to calculate that global component index on the fly, or how do we want to do that? So tx and ty, we're already using so I'd much rather keep the global tx, global ty out of the calculation. However, what if we didn't calculate it over here? What if we did not calculate glodex properly? Glotx, gloty, that looks fine. Map span. Does that part of the logic, like, where does it, what variables should we include? I'm not sure what variables we should include. But that's kind of, these are kind of, calculating exactly where this is calculating the first byte of the calculations. And I don't know if we need that in the calculation or not. So the global component, I'm thinking, is what we want. Like, so here, right, we have glocom plus this and that. That's definitely a variable. So I'm thinking we're going from general to specific. So CPU picks as the data, then glocom is the component that goes into here, right? So it's more specific because, right, general and honing in on something more specific, okay? And then furthermore in the calculation, we then use osdex. Osdex is going to use oslock, and oslock creates the shifting. So I think osdex makes sense as this third parameter when we're trying to order from a general to specific. And I think that's all we need, unless we want, unless what we really want to do here is it's enough information to where if we use this, so we could call it something like, you know, PAINT5D, and we could call it a, since we've been labeling things as put and then with an override, so how about put, it's like, I don't know if I want put or get. I mean, like, we could treat this as an overload, right? So put and the overload is bitpack, or we could say bitpack is the general case, and then this is the specific case. I don't know. I really want this to be a private function that I don't really have to think about much, so I think I'll just call it bitpack put. Even though there's a lot of PAINT5D put functions, but this is not one that I really want to concern myself with much. We might also want to make a note here that, you know, maybe alternatively we were thinking about naming it something else, so we might want to keep that name over here like this, so that if we search for it, if we search for something like put bit, we can still find it, right? And then we can do something like void. Here's our parameters. And then do our stuff. And then we want kind of the same thing again, but instead of a put, it's going to be a get. And when we get a value, so the problem with this is that the well, no, it's not a problem. It's not a problem. A UO8. Make it a UO8. Same data, except we're not putting anything, right? So that also means that in here we have a value that we're putting, right? So this put function, we have a value, the tile value that we're putting. And we should see that being used somewhere down here. Yeah, so right here. Okay, fine. So we know it's called tile value, so and I would rather keep it kind of uniform. So we'll just say that tile, we'll pass tile value like this. We'll pass it as a pointer. So UO8 pointer, because this is an array. The component, not a pointer, not a pointer. Tile value, not a pointer here. So this is the value to get in this case, right? And the reason I want to do this, write it like this, is because if I write the getter like this rather than returning the value, then I can see the exact name of what I'm returning in the code, right? And I think that's going to make the code a little bit easier to read for me. So we're going to take this kind of signature here, and then we're going to do more push-ups. We're going to try to get enough push-ups to where we've done at least 100. Even though we don't feel like working, we want to at least get our exercise in. So we're going to kind of stick to the write code, try to do our 10 push-ups per hour or whatever, or even more this time, because I really want to get to 100. Because once I get to 100, I can be done, right? So the more I do, the quicker I'm going to be done, and I just don't feel like working today. So if we can do that, then we can kind of stop. But we're not going to... We're not going to stop coding until we've gotten all the exercise that we need today. Yeah, so this is kind of what I'm thinking of, that we have these a put function and a get function. And we do our bit packing kind of logic here. So error, extract bit packing logic. So we're going to try to extract the bit packing logic and do tests. And let's make sure that it compiles. What we're going to wait for is wait for these errors to be triggered. Once they're triggered, we're going to do our exercise. Unknown types. So let's define the types we're working with. And we also need to define error. Alright, so undefine them at the bottom of this section. The last time I wrote bit shifting logic, I got it horribly wrong too, and it gave me a headache. So that kind of clues me into saying, I think it's the bit shifting logic this time, because the tests kind of are pointing in that direction. I have a history of getting bit shifting logic horribly wrong. I haven't tested that kind of crazy logic I wrote, so I'm fairly certain that it is the bit shifting logic. This should be, right here, this should be the actual value of this. Should be, right? This is actually what this should always be. In production, it should always be this value. Now, index. The component index needs to be divisible by 4, according to the way we're using our math. What else about this component index? Yeah, this needs to be... Alright, so the offset index is 0 to 15 inclusive. Right, we're just kind of writing a whole bunch of helpful notes. And then we're going to just give it a shot. So we're going to write this code. But first, we want to get it compiling, or not compiling, because one of these things is right. So this is where we are right now. So let's put some underscores there. So that if we want to quickly click on it and search for it in our code base, we can kind of find it. So let's paste that there. Let's run it again. Okay, yeah, so now we can click that, and we can go Control F, and we can kind of find it in both these locations here. So I'm just going to do a git bash here. Git status, git add dot, git commit -am. Yeah, so we're gonna give that a shot. But I just wanted to I would just want to save my work for now. Even though everything's a disaster, I want to save my work and do some exercise. So let's look at my push-ups list here for a second. So we're at only 20, and I'd like to get this done quickly. I'm going to try to go for 80. Might have to do two sets of 40. I'm going to just try to go for 80, just because I want to get everything done and be done. I just want to be done with my code for now. So we're going to try it and see what we can do. And we're also going to set a split timer here, see how long this exercise session takes us. We want to get to 100 really quick. So Okay, so about 15 minutes to do 80 of everything. So that was push-ups, crunches, push-ups, crunches, sit-ups, squats, and then also jumps on the trampoline. Okay, so we got all that done. We got that all the way out of the way. And now the question is, has the exercise made us to where we actually want to finish this stuff, or are we still kind of unmotivated, right? And I would say I'm still kind of unmotivated. So I'm going to stop here, and I know that this is where I have to go next. And we'll try to do that, because you know this is the thing that probably needs to be tested. We need to extract the bit packing logic from this put get stuff here, put it into here so we can isolate it and test it. And so our agenda, so let's change this for a second. So as far as the get, the put, these unit tests, or these actual functionality features, they're done. Right, we can delete that off our list here. The unit test, so these get, so this is done as well. Let's say 5 is done, but we need a new unit test, 6. And, well, actually, we need to write, okay, and then 07, we need to write the unit tests. So now this becomes 8, 9, and 10. And this is supposed to be deleted because we're done with it. Okay, so this is our new agenda here of what needs to be done. We need to write the bitpack put and get bitpack get. We need the unit tests for these new functions. We need to address the fact that the backup function is invalid. It violates the structure of our project right now. We have to reorganize that so it works properly. May make the code a little bit more convoluted, but right now we're violating our library chain structure here for number 8. 9, actual texture push to OpenGL call, and then 10, compile all variations. Okay, so that looks good to me. So that's all we need. That is our new agenda here. So let's look at our next time screen here. Where are you? Agenda to be continued. PAINT5D camera. It's not really PAINT5D camera. It's what we're really working on here now is PAINT5D unit testing. And then after that, we still have a GLSL. So right now we're on unit tests. No, let's just do this. Let's not do that. We're on PAINT5D. Yeah. Yeah. Okay, yeah, we're out of here. Later.